Hey everybody, this is 2014 question number 1 for both AB and BC. Our test is less than a month away, so let's keep on persevering. Let's work hard. Make sure we understand the concepts behind everything we're doing. Steps to take. So here we go. We are looking at grass clippings. They're placing them in a bin, so someone mows their lawn and puts in a bin where they decompose. It's like a compost pile. So it happens for 30 days, I believe. And the amount of grass, this is important. What does this A of T represent? It's actually the amount of grass. Units is pounds, T is days. So you should probably, to make your life easier, say let y1 equal A of T. So I'm going to put that equation, A of T, in y1. But what does that represent? I should write it down here so I don't have to keep reading the question. That is the amount of grass in pounds. I think I have everything I need just in that. So let's go ahead and do part A. Average rate. So make sure you know the difference between average rate and average value. Very distinct. You have to understand this or you'll get problems wrong. You'll mess up. So I'm just going to remind you. Average rate of change. That's also known as a couple of other things. That's the slope of the secant line. And we write that as f of b minus f of a over b minus a. So if you have an actual picture, I'll show you kind of what's going on pictorially. So if you have a function like that, and you find the slope between that and those endpoints, call that m. That is the average rate of change. Over that period, it's the change in y over change in x over a period of time. So it's average rate of change over that whole time period. Now the other thing that you'll be asked for sometimes is just the average value. It's not a rate of change. It's not change in y over change of x. It's just the actual value. This comes actually from the mean value theorem for integration. But you have to know this formula. So you integrate from a to b your function, and you divide it by the width. And that's it. That's just the formula you have to know. We could go to the mean value theorem and explain this. If you remember when I talked about this, this integral gives us the area under a curve. And if you take that area and make it into a rectangle, you divide by the width of the area. Let me get my little... Divide by the width of the rectangle, it gives you the height of the rectangle. So that's the average height of the area of this. So that's why you get the average value from this formula. So make sure you know the difference. And another difference you'll see, rate of change. It's a rate. It's how fast something's changing. So the units of this top one here, F, in this case would be pounds. And the B minus A in this case would be days. So it's pounds per day. It's a rate. How many pounds is changing per day? But average value, which is different, let's look at the units here. This one is pounds. This dx would be days. And B minus A would be days. So you get pounds. That makes sense. The average weight, the average amount of grass would be pounds, not pounds per day. So important that you know the difference. And again, hopefully we're not memorizing, but you're understanding what's going on there. So let me erase this. I need some room here. So we want the average rate of change. That's the f of b minus f of a over b minus a. So we can say part A, the average rate of change, but it's not f because it's a, and the endpoints are 0 and 30, so it's a of 30 minus a of 0 over 30 minus 0. And then we just put in our calculator those values. So you'd actually punch that in your calculator. In your calculator, it would look like this. And let me do that. If you punch that in your calculator, you get approximately negative 0.197. That's if you round off. Or if you truncate, you get negative 0.196. And if you move on to the next problem, you are a sad person because it asks for units of measure. So we need to add the units of measure. So if you look at the top, A is the amount of grass. That's going to be pounds. And then the numbers down here is the time. So that's in days. So that's our units. That's our answer. Bam. All right, part B. They want us to find the derivative of A at 15. Well, that in our calculator is just going to be derivative of y1. Whoops, that's not a y1. Of y1 with respect to time when the time is 15. So put that in your calculator. And if you do that, you will get approximately negative 0.164. That's if you round off. Or if you truncate, you'll get negative 0.163. So just put in your calculator, let your calculator do the work. And if you move on, again, you'll be a sad person because not only do they want that, they want units and they want meaning of this. What does it mean when you have the derivative? So again, it's important you know the justifications, that they make sense, that they're just part of your thinking. You don't have to look to the sheets or search your brain. You should know the derivative. What does the derivative tell you about a function? Whether it's increasing or decreasing should be your thought. That's basic justifications on your sheet. If you don't know your justifications, please review those. Make sure you understand them, not just have them memorized, or you won't be able to recall them when you need to. So we see the derivative is negative. That means A is decreasing. Well, what is A? A is the amount of grass clippings in the bin. So if A prime is negative, we can say the amount of grass clippings in the bin, the amount of grass clippings in, the bin is decreasing. That's what it tells you. That's what it means in the context. Decreasing, how fast is it decreasing? At the rate of 0.164, and they ask for units. So where do we get our units? Well, it's a change in y. That's the amount of grass in pounds. Over the change in time, that's the days. So our units will be pounds per days. Bam, done with number letter B. 2 more to go. Let's keep going. Let's get through this. Part C, find the time when the amount of grass clippings in the bin is equal to the average amount of grass. So the amount of grass clippings in the bin, that is simply A of t, is equal to, and they want the average amount of grass. Well, we need to find that. We haven't found it yet. So the average amount of grass, that's the other formula. Remember we said you need to know the average rate of change and the average amount. The average amount is the integral divided by the width. So the right side, I'm just going to put that in my calculator. So if you integrate y1 in your calculator, divide that by 30, you should get, I need to work this out. Sorry guys, I haven't pre-done that. So I'm going to do, to get the integral, you do math. No, I'm going to get a fraction first, sorry. I'm going to quit this. I'm going to hit alpha y equals and select number 1. So my fraction, the top half will be math 9 to get the integral. I plug in 0 and 30 for the limits of my integration. I'm going to do alpha trace to get y1, and it's going to be dx over 30. And I'm going to get an answer of 2.752635108. Now, how do I find where a of t equals that? How do you find when any two functions equal each other? Well, you just graph them both and see where they intersect. So I'm going to say at, so that number we just found, I'm going to store it as a. So I have that number on my home screen. I'm going to hit the store button above the on button, alpha a. Now it's stored as a. Now I'm going to go to my y equals button. Under y2, I'm just going to graph alpha a. So now I can graph these and see when a of t crosses a, and at the point they intersect, that's the time. So I'm going to go to Windows, and I'm going to put x min 0 and x max 30 because they told us that it's from 0 to 30 days, and x represents the time in this case. My y min and y max, so I just want to know when this function equals 2.752635108. So for the y value, I just have to go from, I'm going to go 0 to 5. 0 for y min, 5 for y max, because 2.7 is roughly halfway between those, so it should give me a graph. I hit graph and see where they intersect. I see it. It's right there. You can't see my graph, but hopefully you're able to do that. So how do I find that intersection point that I see? I do secant trace, which is a calculation of the graph. I find the intersect, which is number 5. It asks me, what's my first curve? And it should have a blinky bob on my first curve. If you agree with that, you hit enter. Then it asks you, what's your second curve? And there should be a blinky bob on the other second curve that you want to intersect. And it should also tell you what the equation is on top, y2. And then it tells you to guess. You just have to get close to it. You don't have to be on the intersection point. That's just in case there's 2. They want to know which one it is. And so you get it closest to the one you're looking for. So I'm going to hit enter, and magically I get my answer. It's going to be at t equals 12.415. That's rounded off. Or if you truncate, it's 12.414. That's C. Now we're going to part D. So after the 30 days, we want a linear approximation. So a linear approximation, you have to know Linear is a line, and the approximation that's a line is also known as a tangent line approximation. So we want to use the tangent line to approximate our function a. So it says it's a better model for the amount of a better model for the amount of grass clippings remaining in the bin. So after 30, the tangent line is a better model. Using L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show your work that leads to the answer. So I want the equation of a line, tangent line. You're asked this so many times. Hopefully by now you know this formula. You have to know it. It has to be right there in your brain. In this case, though, it's not y. We have a's and t's. So I will do that. So they tell you T1 is 30. That's the point of tangency, 30. And we want to know how much grass is there at that point. We found that. Did we find it? We did not, but that's pretty easy. That's just going to be A of 30. And I can pop that in my calculator and get an answer. So that comes out to be 0.782928. Again, you find that answer and you store it in your calculator. You can store that as A again or B, whatever you want to. So just store that for future use. So that gives you those 2 points. Now you need the slope. And everyone knows the slope of a tangent line is the derivative. So we're going to take the derivative at that point, and these should be squigglies. And you just do that in your calculator. Do math 8. It's going to be negative 0.055976. Again, you could store that as another letter, maybe C. The other one is B, however you stored it. But we are ready to rock and roll here. Whoops, that's not a minus. 0.782928 equals the slope negative 0.055976 t minus, oh my, 30. I thought I messed up. Now, to make your life much easier, you could have made this equal to B and make that equal to C. And then you simply would have had this, A minus B equals, C is the slope, T minus 30. Now either way is fine, but they want L of T. L of T is this equation of this line. So if I solve for A, L of T is A, and I guess I'll do this the long way. Plus the 0.782928. All I did is took this equation and I isolated A, and that's my equation of my line, and they want that to be L of T. So they want to know when will L of T equal 0.5. So you would take, wow, I am just so out of room. I'll take my L of T, and set it equal to 0.5. Then you just use algebra to solve this. So if you solve for t, you would get 35.054 days, and there's your answer. Now, in hindsight, you really didn't need this. I mean, you could have used it, and it would have been cleaner. You wouldn't have these long things, but I don't think it was that big of a deal to write out those numbers. It wasn't a lot of work. That's it for this problem. A lot of different concepts there. I hope this was helpful, and we're going to move on to the next problem.